We have been looking at lots of different equations in the form y equals mx plus b. Remember, this tells us two very important pieces of information. For example, the m is what we use for the letter for slope. And we know there's lots of different ways we can express slope. Slope is rise over run. It is y2 over y, or minus y1, divided by x2 minus x1. And remember, we talked about y2 and x2 coming from one particular point and y1 and x1 coming from another particular point. So order does matter. That's because we know that the sign matters to tell us whether our relationship is positive and heading up to the right, or if it's a negative relationship and it's heading down to the right or up to the left. So upward trend versus a downward trend. We've talked also about that being equivalent to delta y over delta x, and that's just the change in the y values over the change in the x values, which really is indicated by these two things. They're really meaning, these are all synonymous to each other. They all mean the same things. One thing I want to make sure that you're clear on is that when you have a slope of 0, we know that your y is not changing at all. There's zero change in the y. So if we go to graph something with a slope of 0, so there's x, there's y, a slope of 0, it means it's an entirely flat line, a completely horizontal line. And remember, lines go on and on forever in both directions. And let's say that is crossing the y-axis at 3. Now if we have a slope that is 0, if we pick 2 points on our line, that first one is at 0, 3. This one could possibly be at 5, 3. If I were to calculate the slope with my slope formula, equals delta y over delta x, or the change in y over the change in x, between the points 3 and 0, I'm rising nothing. My delta y, my change in y values between these 2 points is nothing. Oh, look at that, I have a little smiley face. Now, between those 2 points, however, I do have a run, and in fact my run is 5 units, because if I take 5 from here, there's the 5, and this spot here is really a 0, we know that horizontal distance there is 5 units. So overall our slope is 0. So when we go to write its equation, we can use y equals mx plus b. The m value would be a 0, and the b stands for the y-intercept, which is 3 in this case. And 0 times anything is just 0. So our equation for that line is y equals 3. And in fact, all horizontal lines will have that format where y is equal to a specific number. And that number really is what we call the y-intercept. So right here up on our original diagram, our y-intercept is where our graph is crossing that y-axis. And that's really important. Now I'm going to flip to and I want to look at another example. What happens if we have a vertical line? So if I graph, here's my x, here's my y. If I were to graph a line that's straight up and down, completely vertical, we've talked about this having a particular slope. Let's make this point here with the x-intercept at 5. We've talked about the slope of a vertical line being undefined. Now you might ask, well, why? Why, Mrs. Logan, is that slope undefined? Well, we've talked about slope being the delta y, or the y2 minus y1, over the x2 minus x1. Okay, so I've picked one point on the line. I'm going to select another point on the line. Let's say this point right here. I know it has the same x-coordinate as the one below it because it's a vertical line. It has to go straight up and down. And then let's say that matches with 2 on the y-axis. So that would come across here at 2. All right. So 5, 0 is that first coordinate, and then 5, 2 is our second coordinate. When we go to find our slope, I'm going to take y2. So I'll count this as my y2, 2, take away the y1, the other y coordinate, over my x2, my x coordinate of the second point was 5, and take away the x coordinate of the first point right up here. 2 take away 0 is 2, but 5 take away 5 is 0. And if I try to punch that into my calculator, I get error. Well, what does that really mean? Well, it turns out we can never divide by 0. We can't take a quantity and divide it into 0 units. That doesn't make sense, into 0 pieces. So it's what we call an undefined slope. Now, when we go to write our equation then, this doesn't make sense. What on earth would we possibly put in for the m? And honestly, if we look at this, what is the y-intercept? If I look at my graph, there is no y-intercept. It never crosses the y-axis. So this equation does not work for vertical lines. In fact, if you look at any point on that vertical line, every single point here is going to have the exact same x-coordinate. The rule for that particular line is that x has to equal 5. It doesn't matter what y is. Y can be anything, but x must equal 5. So the rule for vertical lines looks like this. X equals, and I'm going to put the letter A in here. We use B for y-intercept. We use A for the x-intercept. X equals A, where x is the x-intercept. So x is our x-intercept. So that's the equation for a vertical line in general. Now, the way you can remember it in terms of all of these things, if you think of a coordinate, when we write our coordinates, the x-coordinate comes before y, and in the alphabet, x comes before y. When we're looking at x-intercepts, x comes before y, and A comes before B. If I went back to my other slide, I had y equals B for my horizontal line. Y is after the x, B is after the A. So it's all alphabetical order for you, for those people who have trouble remembering things like I sometimes do. So I've introduced a couple new concepts in terms of x-intercept, and which we haven't talked about a lot, and y-intercept. Go to a new slide here. Now, we have equations for lines that have been written in that form y equals mx plus b, such as negative a half x plus 5. And we've talked about how we can graph that. I know I would put a point on my y-axis at 5. And then my fraction, I have a negative 1, so I could fall 1 unit and then run positive 2 to the right. And there we are. So I would have another point here. And I could fall another 1 unit, and run 2 more to the right. And this would work much better if I had an exact grid on here. I could fall another unit and run 2 to the right. And that helps me to create, if I were to join all those pieces together with a nice ruler, if I wasn't just using my finger on this iPad, it helps us to join the equation. Now when we graph it, we want to span the entire axis. We want to put arrows on both ends because it goes on forever and ever. And our last step of properly graphing would be actually label the line with its equation on the graph. So there we are there. Now, so we've talked about that. We've talked about ways to graph with tables of values as well, but this is a much quicker way to graph. Sometimes, however, we're given equations, but they're not in that format of y equals mx plus b. And then we have to use our rearranging formulas to help us get to that next level, which I will do on another slide, or on another movie. Sometimes we're given equations in another form, such as, let's say we have, I'll write this in blue, x plus 2y minus 10 equals 0. Now this isn't as easy to graph because what on earth does that look like? I don't know the slope, I don't know the y-intercept because that's not in my familiar form of y equals mx plus b. If I have it in that form, it's very helpful because then I know how to graph that. I've really got two options here for graphing it. I'm going to show you the first option just since we finished up with solving equations. If I were to actually isolate my original equation for y, I'm going to get y by itself, get everything on the other side. That would set it up in this format. Now if I look at what's there, I know I have an x with the 2y and I have a minus 10. So I want to get rid of those two things, the x and the minus 10, by crossing the bridge and switching the sign, or adding the same amounts to both sides to get rid of them. So really I want to add x here, which means I'm adding x on this side. Sorry, my bad. That should be a subtract. Now let me see if I can get my eraser going here. Oh, good, I found it. Okay, so I really want to subtract x there from both sides. And I have a minus 10, so I really want to add 10 to both sides to undo that. So on my left side, I'm going to be left with a 2y. And on the right side of the equal sign, I have a minus x plus 10. All right, now to get my y by itself, it's being multiplied by 2. So to undo that, I'm going to divide every term to keep it fair, to keep it balanced, to keep it equal. Every term gets divided by 2. So 2 divided by 2 on the left side just leaves me with a y there, which is good. That's exactly what I want, to have these formats the same. And then I have a minus x over 2. There's really not a lot I can do with that. And then plus, and 10 divided by 2 is 5. Now, I know to figure out my slope. My slope is the thing that's multiplying the x. So I'm just going to rewrite this as a, oops, now I know my eraser. There we go. Y is equal to, and then I have negative something over 2x. What could go there? Well, we know that when things are missing in front of our variable, the coefficient is automatically a 1. So that's really negative 1/2. So our slope would be negative 1/2, and we still have the plus 5. So our y-intercept is plus 5. Now I chose this example here because these are the exact same equations. The equation I gave you in the first little part here is what we call the standard form equation of the line, and not the most helpful form because it doesn't tell us a whole lot. We sometimes have to take that standard form and rearrange it in the y equals mx plus b form if we need the slope and the y-intercept. We don't always need that, but sometimes we do, and it's helpful for graphing. So that's our focus here, is to try and rearrange those equations in their format of y equals mx plus b. The standard form of the line, of the equation line in standard form, we're looking at ax plus by plus c and equals 0, and those are all capital letters. The a, the b, and the c are really all integer values. So integer values. And we know that a and b cannot be 0, are not equal to 0. If we have that, we know we can change it around into y equals mx plus b form, or the slope y-intercept form. Now, if we arrange that into the slope y-intercept form, we know that we can get our slope and our y-intercept from that, which becomes helpful. So just as a quick example here, to recap, we're going to take the equation 3x plus 2y minus 7 equals 0, and we're going to rewrite that in the format of y equals mx plus b. Now I've got y right here, and I've got two things, actually three things, the 3x, the minus 7, and the 2, keeping the y from being by itself. So I'm going to subtract 3x from both sides. I have a minus 7, so I'm going to add 7 to both sides. And what I end up with then, on my next line, I'll be left with 2y, and it's still positive because this sign always travels with it. We don't normally write that in there, is equal to negative 3x plus 7. And then we want to undo that 2, which is multiplying the y, by dividing everything by 2. Now I could have put the 0 and the 7 together first, which I forgot to do, but that's okay, it'll all work out. So 0 divided by 2 is really 0, and it really disappears. That leaves us with negative 3/2 x. So our slope is negative 3/2. We know then we have 7/2 as our y-intercept. 7/2 is the same thing as 3.5. Because my slope is a negative value, I know that my line should go up to the left or down to the right. It should be a downward trend. I also know that it's greater than 1, which makes it more steep than it is flat if I use a scale, the same scale on the x-axis as I do on the y-axis. So if I'm going by 5s on the x and I go up by 5s on the y, then I know this will make an angle that's greater than 45 degrees with the x-axis. Okay, so it is more steep. Now, of course, I could change my scale and then I can play with what the steepness is, but in terms of just in general, it is rising more quickly than it is running. So it's more steep than it is flat.